So we're going to restrict the domain of g of x to line up with the inverses of h of x and j of x. But before I do that, I always verify that they are, in fact, inverses. And this is what we've done on the previous problems. So I'm going to type in y equals to x. There's our line. You can tell that one side reflects over that black line to the other side. So we do have sets of inverses. And then the other way is to go ahead and do a composition of h of x into g of x and then j of x into g of x. So I'm just going to do that because I love to verify these things. I hate to make a mistake. I do all that work to make a mistake. So I say g of h of x. Notice that line lights up with a different color. And then I'm going to do the same thing, g of j of x. Okay? And notice, once again, it switches out again. So they are, in fact, inverses. Now that I know that they're inverses, because they line up over, the compositions are over y equals to x, I'm going to come back. Now I'm going to restrict the domain. Okay? And when I do that, I look at y equals to x. It just helps me out. I know that this green graph right here will line up with either this side or it will line up with that side right there. So I'm going to turn off the purple one. And we're going to work with one of those, okay? When I restrict the domain, the first thing I'm going to do is come to the vertex. And the vertex is at 1, 2. So I know x equals to 1 is where I'm going to be restricting the domain. The second thing I'm going to do is I'm going to come up into the original equation. And I have to put my brackets, and I have to say, well, what side of 1 do I want? Do I want down here? Or do I want up there? So what I'm going to do is I'm going to say, well, let's check for x greater, or let's start with this side right over here, which is x less than 1. So I'm going to take x less than or equal to 1. And what I'm going to do is I'm going to look at it. And I'm going to say, okay, well, let's check if this is the case. Are they inverses? Visually, I can tell that they are not reflections over the black line. However, if I want to check this another way, I can go back to the composition and I can say, well, let's check g and h of x. So g and h of x, let's turn it on. It doesn't light up. It doesn't change colors. They are not inverses of each other. So that doesn't work. So what I'm going to do is I'm going to say, okay, well, I must have been using the wrong side of that parabola. So I'm going to type it in a different way. I'm going to say x is greater than or equal to 1. Okay? And now when I do that, I'm going to go back and say, okay, those look like inverses because it's a reflection of the black line. But I'm just going to go ahead and check it. I'm going to say, well, let's check this out. H of x and g of x and see if it changes, and it does change. They are in fact inverses because they were right on the line y equals to x. Okay, so this is my domain restriction. I can graph this for x greater than 1. This is the inverse, as long as it is x greater than or equal to 1. Only h of x is the inverse. Now, after that, what I'm going to do is I'm going to go ahead and just put up the original one, and I'm going to go here. And what I want to know now, turning it back on, is, well, what about j of x? Well, what is j of x? So let me turn that one on. Okay, j of x is right there. I'm going to go back to the 1, and I'm going to say, well, maybe that one is the less than 1. So I'm going to put bracket x less than or equal to 1 and check that out. Those look like inverses. And now I turn off this one. I put, let's turn j of x into g of x and look at it, and boom, it lights up and changes it. So in this case, when it's less than or equal to 1, when the domain restriction is x less than or equal to 1, it is j of